Verify some trig identities. Verifying trig identities. Hello, it's your instructor again. We're going to verify a few trig identities. Now, this is to me one of the most fun parts in trigonometry. It's just a great little puzzle, that you can play with. And, some people say it's one of the most useless skills in all of mathematics. I mean, when are you ever going to use this? Well, when are you ever going to use level 472 of cookie jam? Or, oh man, I'm the 1,178th best player in Mortal Kombat 10. I mean, really? We could argue all day long that this little thing right here and this is a lot more fun, trust me. Verifying trig identities. Let's just get right into them. This is a trig identity. Somebody's telling us that it's true. So what do we want to do with it? I mean, do we want to do anything with it? Yeah. Let's pick an ugly side. Well, they're both ugly. And we're going to take that ugly side and try to make it look like the other side through a series of algebraic operations or through substitution with other trig identities. So let's just play with this for a second. I want to turn the sine of t divided by 1 plus the cosine of t into this. And you're saying, how in the world can we do that? Well, remember, with verifying trig identities, you pick one side and you manipulate it until it looks like the other side. And sometimes in some textbooks and some sites, you'll see these little things that look like this L, H, S, and R, H, S. And students go, what is that? Left-hand side, right-hand side. What I'm going to do is I'm going to work on the left-hand side. And all I want to do is this. I want to make this look like that. Well, how do you do it? Well, notice that this has 1 plus the cosine of t in it, and this one doesn't. So, let me get 1 minus the cosine of t in the left-hand side by simply doing this. The sine of t divided by 1 plus the cosine of t, if I multiply the top and bottom by 1 minus the cosine of t, I am multiplying by this one's conjugate. So, what happens when I multiply these bad boys out? Well, let's find out. Here I've got to use FOIL in the denominator. 1 times 1 is 1. The outer and the inner cancel each other out. And I'm left with minus the cosine square of t, which is pretty awesome. The top becomes the sine of t times 1 minus the cosine of t. You're saying, well, why don't you distribute that out? Well, look at what I'm trying. I'm keeping the end in mind. This has 1 minus the cosine of t, and I've got it there now. But I've got to get rid of this 1 minus the cosine of t. Come on. Come on. Whenever you see anything being squared, the first identity that should pop in our mind is the sine squared of theta plus the cosine squared of theta equals 1. And then looking at this, if I subtract the cosine squared of theta on both sides, I end up with the sine squared of theta equals 1 minus the cosine squared of theta. In other words, and I could also, for some of you really looking at it, I could have just said the sine squared of t equals 1 minus the cosine squared of t. That variable is irrelevant. So what happens is I can now substitute the sine squared of t in the place of 1 minus the cosine squared of t, and I'm with the sine of t times 1 minus the cosine of t, the numerator, all divided by the sine squared of t. And now we see what happens. These two, one of these can cancel out, and I'm left with 1 minus the cosine of t, all divided by simply the sine of t. Because pew, pew, which is the same thing. When verifying a trig identity, you almost have to act like a lawyer. You don't want to do too much in one step, or you lose everybody. This person was caught with a knife in their hand. They had blood on them. He had ice cream later. Wait, that makes no sense. We left off some steps in there. So the same thing with verifying a trig identity. You want to make sure from this step to this step that the average person would look at it and go, okay, I think I see what you're doing. And of course, we have to take into consideration that we do know some algebra. So awesome. Let's look at this bad boy. start with the ugliest side. Well, they both look mighty ugly to me. But here's a simple tip. If you're not sure what to do, you may do something that doesn't work, and you'll go back and try something else. So you're not going to do these perfect every time. So you want to try several different things. So like one technique that a lot of students use is they'll say, well, tangent of theta, I'm just going to change everything to sine and cosine. That makes me feel better. Cotangent is cosine of theta over the sine of theta. And then you're like, well, that doesn't look like that. Well, of course it doesn't. I mean, this is being multiplied together. This is being added together. So let's add these two fractions together and see what happens. And keep in mind, when you add fractions, you have to have a common denominator. So here, our common denominator is going to be the sine squared of theta times the cosine squared of theta. So what happens here is I'm going to multiply the cosine of theta times the sine of theta. But if I do it on the denominator, I have to do it on the top. So there's already a sine of theta there. So by multiplying the bottom by sine of theta and multiplying the top by sine of theta, this becomes sine squared of theta. Over here, this is sine of theta. I'm multiplying the denominator by the cosine of theta, which means I need to multiply the numerator by the cosine of theta. And it already has one in it. So that's cosine squared of theta. So adding these two together, I have sine squared of theta plus cosine squared of theta, all divided by the sine of theta times the cosine of theta. And the sine squared of theta plus cosine squared of theta is equal to 1, using that same old identity again. So this is 1 over the sine of theta times the cosine of theta. And keep in mind, we can switch these around. We can do whatever we want to. We can write this as 1 over the sine of theta times 1 over the cosine of theta. And guess what? 1 over the sine of theta is your cosecant. 1 over cosine of theta is your secant. Multiplication, order doesn't matter. So we have verified this identity. Beautiful, beautiful. So keep in mind, start with the ugliest side. If one side's uglier than the other, change everything to sine and cosine. It's one technique. Use algebra, adding fractions, multiplying fractions, think about conjugates and so forth. And also, you must have in your brain a series of these old identities. A sine squared of theta plus cosine squared of theta equals 1. We need to know, hey, what is tangent of theta equal to in terms of sine and cosine? What's secant and cosecant? So keep that in mind. Verifying trig identities. Watch this video again.